Section 10.3 is on compound interest, but before we get in there, let's go ahead and do a couple warm-up problems. We're halfway through Chapter 10, so it's worthwhile to look back at Section 10.1 and 10.2 just to make sure we're comfortable with the material already covered. So, number 1, 8% of what number is 10? So back in 10.1, we learned about percentage, and we had a formulation of it. Namely, that a percentage could be considered as part of a whole is equal to the percent as a decimal. So with this in mind, we can go ahead and set up basically an algebraic equation that we can solve to answer this question. So if we look at this, clearly we're given the percent. So 8% of what, so this is our unknown, is 10. If we recall that this of is a good indicator of the whole, and then 10 is going to be the part. So to go ahead and set this equation up, we have 10 out of the whole, which we'll just label as our unknown, so we'll call it x, is equal to 8%. But of course, remember 8%, we need to convert that to a decimal, which is 0.08. To solve this, we're just going to cross multiply. So again, whenever you have an equal to sign, you think about cross multiplication. And this 0.08 is over 1. So I'm going to multiply the 1 and the 10, and then the 0.08 and the x. So that gives me 0.08. X is equal to 10. Lastly, we divide both sides of this equation by 0.08. And that will go ahead and give us our x. A quick little computation on a calculator, you will find that x is equal to 125. So, and just think about this, does this make sense for being a whole? Well, it's much larger than 10. And again, 8% is not very large, so yeah, 10 is probably about 8% of 25, and you can verify that by just multiplying the 125 by 0.08. So that is section 10.1. Number 3 is very similar. I would encourage you to pause the video right here and give number 3 a try. What you should have found is that x is equal to 36.36. Again, same setup as the one above. So now on to number 2. Use the simple interest formula to find the missing value. So the simple interest formula was I is equal to P times R times T, where I is the interest, P is the principal, R is the rate as a decimal, and T is the time. Of course, remember that R and T need to be in the same unit, and you might need to use the banker's rule, which that is to say, a banker's rule is there's 360 days in 1 year. Here, we are not specifically asked to find the interest, but we're asked to find time. So a little bit of setup first. It might be worthwhile to rewrite the rate as 3.75%. Again, this 0.75 is just 3/4. Again, type that into a calculator if you need to go ahead and verify that. And again, we need to go ahead and work with the rate as a decimal. So I'll go ahead and just rewrite it by moving the decimal place 2 places to the left. Now we'll go ahead and set up the equation. So $351 is our interest, so that'll go on the left side. I'll just drop the dollar sign to keep the unit, to keep the value or the equation a little cleaner. So that is equal to 800 times 0. Let's write the 0 in front. I always like to write the 0 in front. 0.0375 times t. To solve this, we'll just have to go ahead and divide both sides by this constant in front, which is the product of 800 and 0.0375. So divide both sides by that product. One thing that I would make a recommendation is if you want an exact value, don't do any rounding. So you could go ahead and multiply this out, and if you multiplied 800 times 0.0375, you'd end up with 30. So it comes out to be a nice number in this case. So it would be fine. But remember to use all of the decimals if you can. So, or if it's irrational number, or there's a lot of decimal places, make sure you get as many as you can. So to do this in one calculator press, though, I would just do the 351, and then I'm going to divide that by 800. And then don't multiply here because, again, this is on the denominator, so I have to, again, divide by 0.0375. So what we get here, after we simplify all of that, is going to be 11.7, and on the right, everything will cancel except for the t. 800s cancel, the decimals cancel, so t is equal to 11.7, or you would more commonly write the variable on the left. So 11.7 years. Again, if you wanted to go ahead and get this in days, remember you would just have to multiply that by 360 days per 1 year. The years would cancel and you would have a unit in days, but that's just, again, a quick reminder, which we already did up here. So you'd find that this problem down below is very simple, or very similar. We're just asked to find the principal instead. So and again, notice here that the units for time and months are the same, so you don't need to do any conversion. If you worked through this right here, you'd find that the principal to the nearest dollar is 222.22. Wow, hopefully that's not too much. Probably not. $222.22, I'd take it. So again, pause and verify that if you're not sure. And then we'll go ahead and begin section 10.3. All right. Section 10.3 is on compound interest. To go ahead and start with some definitions, you may want to pause the video here just to go ahead and write them down and get them in your mind, but we'll go over them now. So we have been talking about loans. So loans, of course, is the scenario where we borrow money from a bank. Oh, maybe I'll write these words here. We've been talking about loans where we, as the borrower, gets money from the bank, and of course, then the money that we get is called the principal. So that's the amount borrowed. And then, of course, we are charged interest, which is the cost to borrow. So we can also do this the other way. You could, when the bank borrows money from you, it is referred to as an investment. So the investment, you give it to some organization, and they will do whatever they want with it. There's certain rules and regulations, but that the investment is you are using money for income or for profit. There are two types of investment. The first one is a fixed investment, which is guaranteed, and the interest is computed at a fixed rate. Guaranteed means that the amount invested will be paid back with interest. These are very safe, such as savings accounts. As of 2022, the interest rate on my high yield savings account is 2%. It's not a lot, and that's per year. Certificates of deposits, these aren't as common, but my parents had some of these that were even like 20%. So a CD, you could look in the details. Essentially, you invest money, and then after a certain number of years, you're allowed to go ahead and cash that CD in and get money with the interest, the guaranteed back. So these are very safe, but they are not. It's kind of that whole risk versus reward. A little not as risky, less reward. A variable investment. So neither the principal nor the interest is guaranteed. You could lose everything. I mean, you could put in $1,000 and you may lose $1,000, which is the principal. You may not, and you don't get any money. So this is, of course, what happens when you see like stocks failing. Mutual funds are safer because they're diversified, and you even have bonds. So again, this is the stock market. So again, some people really watch the stock market because this is, I don't know, it's almost a little bit like gambling. I've heard it's called as the stock market, and is the rich man's gambling. But there are safe ways to invest in the market, and typically mutual funds is one way. So not as risky. But they're still risky. It is a variable investment. All right, so what we're going to do is introduce the terms or the definitions for simple interest and compound interest and see how they are related on the next page. So simple interest is calculated once for the period of a loan, which is what we've been talking about, or today a little bit more as investment. Of course, we learned about this last class. I is equal to P times R times T. So we will calculate how much interest this investment or loan gets one time for the entire period of the loan. And again, the period is just related to how long or how much time you borrow the money for or invested it. Compound interest has a little bit more computation to do. So it is again computed on the principal and any accumulated interest. So again, maybe the keywords that are different: simple interest once, but the accumulated interest is also going to be considered as more interest is computed for a compounding interest investment or loan. Again, a loan just is when you're borrowing and someone else is making money off of your money because you have to pay it back, and investment is you give your money to someone else and they're going to give it back to you with the interest. So let's go ahead and write the formula, break it down. There's a lot to put here, so let's go ahead and first just write it. So A, which is the accumulated amount, I'll put that off to the side in a sec, so leave some room over here just to put that stuff there. So A is equal to P times 1 plus R over N, all to the N times T. A lot going on there, but there is some tips on how to calculate it. So again, as you go through this lesson, I would encourage you to pause and always do the computation yourself just to make sure that you're comfortable with it. So A is the accumulated amount, and the accumulated amount is going to include both the principal and the interest. So again, notice there's no interest in this formula, so it's a little bit different than the previous one. P is still the principal. R is going to be the annual rate as a decimal. And N, I'm going to put N in green or a different color. We'll have to talk about N a little bit more. It is the number of compound periods, such as yearly, monthly, daily, so on, and I'll write some common ones here in a moment. And then T is the time. On the other side of this box, let me go ahead and just do a couple different compounding periods. So we'll do so these are your different values of N. We have daily, and hopefully at this point you've noticed the banker's rule says if something is computed daily, it'll be computed 360 times. Something that is done monthly is just the standard 12. Quarterly, there's 4 quarters in a dollar, there's 4 quarters in a year, there's 4 seasons, so quarterly is 4. Semi-annually is 2, and annually is 1. So these are different values for N. All right, next, really before we get into any sort of fancy problems, let's go ahead and make sure you're comfortable working with this on a calculator. To make sure that you get these numbers, you really need to make sure that you do them all in one step. So my recommendation is, honestly, these are always going to be nice numbers, the n and the t. So n is going to be one of these nice round numbers we get here. Time is going to be years. So yeah, let me go ahead and write that. So it's going to be time in years. So it's always going to be some nice. It's not going to be any sort of weird decimal. So what I'd always recommend up front is just to go ahead and compute this. 12 times 2 is 24. That just takes away one of the button presses. So then you only have to do the 24 here instead. So that would be my recommendation. So to do this, and I'll kind of do it alongside you. So go ahead and clear everything out, and we'll first start by just computing this this fraction. So 0.018 divided by 12 and hit equal. So after each one of those, I'm going to go ahead and hit equal. Secondly, I'm going to go ahead and add 1 to that. So plus 1, hit equal. And then we'll go ahead and do the exponent. So the third thing you'll do is this 24. And let me go ahead. It'll vary a little bit, but on this calculator I have on the screen, it's going to be this x to the n button. So I hit that. I'll hit 24. I'll hit equals. And then lastly, let me get a new color right here. I will multiply this by 3,000. So when all is said and done, you can see that, I think I only did 100. Yeah, so I only did 300 there. So again, I have to actually multiply it by another 100. So mess that up there. Oh, I had to multiply it by another 10. Okay, so let's do that again. 0.018 divided by 12, hit equal to, add 1, hit equal to, hit the exponent button, type in 24, hit equal to, and then multiply by 3,000, and we get this matching value right there. So that's how you could do it by breaking it up. You don't have to worry about the parentheses as much, but go ahead and spend some time to make sure that you're comfortable with computing that formula. If you're unsure, make sure you talk to the professor or me before the test. All right, so now that we know how to compute the compound interest, or actually it's the accumulated amount. So again, this right here is the 3,000, and then you check the interest. It would be $109.88. More on that in a bit. Let's go ahead and see how you could do this same computation by just using the simple interest formula, and how, while it's a fairly complicated formula, realize that it does simplify a lot of kind of steps in the process. So here's the little scenario we'll use to illustrate this. Suppose that you have $2,000 to invest over 5 years. You deposit $1,000 into a savings account that is $5,000 or 5% simple interest on the $1,000 each year. So again, this is basically, it's going to be a 5-year loan. So what you can go ahead and do is, let's go ahead and just consider how much is going to be in that account after 1 year. So account A, again, is going to be, I'll just do the computation off to the side. Account A is going to use simple interest. Simple interest is the same formula from earlier. I is equal to P times R times T. So I is equal to 1,000, our initial investment, times 5%, times, again, 1 year. Let's see how much is going to be in there. So after 1 year, it is going to end up being 1,000. And again, if you did this, you would find that it's going to be $50. So you'll have $1,050 in that account. All right. So next year, you would get another 5%. So you would, and again, it's going to just be on the principal. So you have 1,100 and, just 1,100. After 3 years, you'll have 1,150. After 4 years, you'll have 1,200. And after 5 years, you'll get 1,250. So it has 5% simple interest each year. So notice that This $50 we're not getting any interest on. This $100 we're not getting any interest on, and so on. So we could go ahead and find. Let's go ahead and consider account B. Account B, you deposit $1,000 in a saving account, and it pays you 5% of the current account balance. So this is getting the idea of compound interest each year. So after the first year, you'll end up with still the same amount. So it's just going to be, you had $1,000, you're going to have $50 right here. Okay, and if you were to now go ahead and compute that same simple interest formula, but include the 50, so like, let's just do that off to the side. I'll just do it right over here. If you were to go ahead for the next year, the interest, if you were to go ahead and compute from the 1,050, including that now in your account balance, still multiply that by the 5% and one more year, you're going to find that this number is going to be, I'll put it on the left, 52.50. So 52.50. So that extra $50 got us an extra $2.50. So then this would be $1,102.50. If you did this same kind of thought process for the next 2-3 years, ultimately you would end up with $1,276.28 in that account. Doesn't seem like much because it's still a small value, but realize that something that's compounding, a compound interest, so the interest is including in the next computation, you get an extra $26 when all is said and done. So this is a little slow because we have to keep running this formula every year and we have to keep updating our principal. So what we're going to do is just use that formula to verify and get the same number. So let's go ahead and just write everything down. The principal was, here, let me write my pen a little thicker. The principal here was $1,000. The rate was 5% annual, so 0.05. It was compounded each year, so N in this case is 1. It was a yearly compounding, and it did it for 5 years. So the account balance, or the accumulated account, is going to, again, be P times 1 plus R over N to the NT. So plugging this in, you get 1,000 times 1 plus R, which is 0.05, divided by 1, all to the N times T. So again, I recommend just doing that computation ahead of time. It's 5, so pretty easy here. So let's go ahead and I'll do it on the side here just to see how it goes. So again, I will first do the fraction, so 0.05 divided by 1, hit equal to. So that's done. Add 1, hit equal to. That's done. Raise it to the 5th power, so x to the n, or you might see a caret button or something like that. So raise that to the 5, and then now multiply it by 1,000. So you see, you get the $1,276.28, which is the same value we got right here. So when all is said and done, compounding interest is nice because account B gets us an extra $26.28. How much interest did it get in total? Again, this is the total amount, or the balance in the accumulated amount. So the $276.28 is the interest, if you just kind of ignore the principal. So again, this is does kind of muddy the waters a little bit when it comes to comparing interest rates. So the APY is something that is legally required to be publicized whenever a bank is making these accounts. It is the simple interest rate that gives the same amount of interest as a compound rate over the same amount of time. So basically, what would the interest on this computation need to be so that you get the same account right here? So again, this is going to have to be a little bit higher. So if we were to consider the I have an example right here. Let's say we had 5% interest, and it was compounded annually. Well, actually, hold on. What did I say? Add monthly here. Okay, yeah, so it's compounded annually. What you would have right here is a 5.127% APY. So if you were to have a compounding, you would have 5% interest compounded annually, then this would just be 5.71 APY. This would be a simple, the rate you would use for the simple interest formula to get the same right there for the compound interest formula. Okay, so that is how it relates. Now we just got to do a bunch of problems to make sure we're good with it. So I would encourage you, before you hear the explanation, to just pause to see if you could read it through a few times to make sure you understand what's being asked, and then to go ahead and maybe try it. But if you're completely stuck, feel free to keep watching, and there's some additional exercises after these. So number 1, we're asked to calculate the total accumulated amount, or the total amount accumulated on $1,000 at 1.4 compounded quarterly for 6 years using compound interest formula. So one thing you will want to note as you get ready for the test is read it carefully and figure out what formula you're going to need. The compound interest formula is the one that we use here. So I also underlined the A, which is we're asked to find the total account value, or accumulated amount. That $1,000, that is our principal. That is how much was initially put into the account. The rate is 1.4%, or 0.014. So here's the new terms. New term N in this case is compounded quarterly. So quarter, there are 4 quarters in a year. And then lastly, time for 6 years. So a lot of variables, but A is simply going to be equal to 1,000 times 1 plus 0.014 divided by 4, the N, all raised to the N, which is 4, times the T, which is 6. So again, that's 24. You may just want to do that computation ahead of time just to have that taken care of. All right, I'm going to go ahead and put this off to the side. So that right there is 24. Okay, so again, let's go do the computation. I'm going to do it just one piece at a time. So do the fraction first. 0.014 divided by 4, hit equal. Add 1, hit equal. Raise it to the 24, so hit equal. And then finally multiply it by 1,000. So that gives us a account value, or the total accumulated amount. It's $1,087.47, just rounding there. Okay, so that answers the question, but just to make sure we're okay with what we're looking at, suppose we were asked to find the interest. Again, the interest is going to be what is in the account, but then you take away the principal. So if you do that, it's just going to be that $87.47. So that's how much extra you get for investing in an account that with those values. Okay, that's going to be important for the next one, where you're asked to actually calculate the interest. So I would encourage you again to pause, see if you go do it. Here we go. So again, we're calculating the interest, and my cat is here, so don't mind her. She is just excited that I'm giving her some interest. Okay, good girl. All right, so calculating the interest. So again, I'm going to just write that as what I'm missing. I'm also going to remind myself that this is A minus the principal. All right, so our principal is going to be $3,000. So there's our P. Our rate is going to be 0.04. Again, just converting that to a decimal. Again, compounded, I didn't call it out this time, but that should at least immediately make you think to use the formula with all these variables. Then n comes next, so semi-annually is 2, and t is 7 years. So in this case, a is equal to 3,000 times 1 plus 0.04 divided by n, which is 2, all raised to the 2 times 7. Oh, gotta have my 2 times 7, which again, 2 times 7 is 14, so just kind of do that ahead of time. Okay, so let's go ahead and do the actual computation here. I'll show you again. So I'm going to start with the fraction 0.04, divide that by 2, hit equal, add 1, hit equal, raise that to the 14, hit equal, multiply that by 3,000. So this is going to be 3,958 and 44 cents. And you might be like, okay, I'm done. But remember, we're asked for the interest. Like I said, a problem like this might be a little tricky on an assessment because you get a value and that might be one of your options in a multiple choice, or probably will be actually. I'll try to even disguise that. But you want to make sure you get the interest. So I is equal to that value we got, which is the 3,958 and 44 cents. And when you take away, in this case, the 3,000 that was initially invested, and that gives you 958.44. And you have the interest, which is the final answer to this one. All right, let's look at number 3. We have a scenario here. Mary is a good singer and wins $2,500 in a singing contest. Being the savvy person Mary is, she invests the money in a 4-year CD that pays 3% interest compounded monthly. How much will Mary receive when she redeems the CD at the end of 4 years? So again, how much money will she receive? This is the accumulated amount that we're looking for. So again, A is our unknown. It is compounded monthly. So again, that's going to make me think that I need my compounding interest formula if you didn't realize the A already did. So let's see what else we got. P is equal to 2,500. T was 4 years. So there is our P. There's our T. Our rate is 3% or 0.03. Our monthly, there's our N, so that is going to be 12. And we have everything we need to go ahead and compute the accumulated account balance, which is going to be 2,500 times 1 plus 0.03 divided by 4. Divided by 12, excuse me. All raised to the 12 times 4. And of course, 12 times 4 is 48. I've done the calculation a few times. Go ahead and verify that you get $2,818.32. All right, I think we have 2 more problems in this lesson that are a little bit different than those 3. Rebecca needs to replace her roof in 5 years. How much should Rebecca invest now in a money market account that pays 2.1% interest compounded quarterly in order to have 5,000 or 6,000 5 years? So Rebecca, which happens to be my wife's name, is needing to get her roof replaced, which also happens to be something we're in the process of right now. Unfortunately, I think it's going to cost a lot more than $6,000. So if, let's say, we were to tell our past selves, let's go, this is coming, start saving. How much should you invest now so you have some extra money just set aside with the interest to pay this off? Okay, so let's see what we have. This is a compounding, so that is immediately going to tell me I'm going to need to use the compound interest formula. So let's see what we have. How much should she invest now? Invest now, that is our principal. So this is our unknown. Okay, let's see what we got now. T is 5 years in this case. How much should Rebecca invest now in a money market account that pays 2.1% interest? So again, that is going to be 0.021. Quarterly is our N, so that's going to be 4. And 6 years. In 6 years' time, we want the account or the accumulated balance or amount to be $6,000. So this is very similar to the second type of problems we encountered with simple interest. Is we just have a different variable. So A is 6,000. P is unknown. And then we have 1 plus 0.021 divided by 4, all raised to the n times t. So 4 times 5, which is the 20. So to do this, we need to basically take everything that is right here, and we need to divide that, I'll put it in red, to the other side. So that would leave us with P is equal to 6,000, and then we would have this big quantity, 1 plus 0.021 divided by 4, all to the 4 times 5, or 20. If you wanted to write that, that's fine. And then that's, again, a little bit harder to compute. But this right here, this right-hand side is P equal to A divided by 1 plus R over N to the NT. This is sometimes referred to as a different formula, which is the present value of money formula. That one won't be distinctly given to you on the test because it's just a rearrangement, but it is definitely kind of representative of this situation. Like, how much is something worth right now if you were to consider it in the future, or how much is what you have right now worth in the future? That's the better way to say it. How much is what you have right now worth in the future? If you're investing it, it's going to be worth more. That's what we're going to find. So, how much is 5,000? What is the principal? So, unfortunately, this computation is a little bit nasty to type on a calculator. So, if you need an exact value, just use lots of decimal places. So I did this, and you get I got 1.110455799. Wrote that down, and it gave me a pretty accurate value. The principal here is $5,403.43. So if Rebecca invested this now into this account with these values, then in 5 years she'll have the $6,000 she needs for the roof. So hey, an extra $600, not bad. Lastly, we're going to look at another little kind of computing trick called the Rule of 72. This is a simple formula that can help you estimate the numbers of years required to double your money. So you simply divide 72 by the interest rate, and this is where it gets a little weird, without the percentage sign. So you don't actually write it as a decimal. You just do 72 divided by the rate without the percent. So it feels a little bit different, and this will tell you how long it takes, or the time in years, to double your money. So we have a scenario here. approximate how many years it will take to double $1,000, or how long it will take for $1,000 to turn into $2,000 to double at a 3% interest rate. So we'll do 72 divided by the percent or the rate without the percent. So that's just 3, or if you write 3%, you erase the percent. So that is going to be 24 years to double $1,000. So if you're comparing rates and you're like, how much should we put here? And you're like, I want to double this much. And you could look at the account and just look at its interest rate, and you could just eyeball it. And again, we can verify this. Let's go ahead and do that. Let's go ahead and verify in a compounding interest account, which starts with $1,000. We have 1 plus 0.03, so 3% rate, unless it compounded just yearly. It didn't give us any better compounding, so it's just how many years. You raise that to the n times, and the rule of 72 told us 24 years. If you go ahead and type this in to a calculator, you're going to get $2,032.79. So you'll do a little better than doubling, but it did take a long time to turn 1,000 into 2 at an interest rate of 3,000 or 3%. So that's compound interest. It's much compounds much faster, so it could work for you in the case of investments. And most loans are actually compound, so you want to be very careful with your money. Pay off debt. That's like Dave Ramsey is a Christian financial advisor. His big thing is to get out of debt. He says the only debt that he's really okay with is mortgages, which is what we're going to talk about in 10.4. But again, get out of debt and start using compound interest to help you make money by investing. There is some additional exercises. I would encourage you to work through these. And of course, remember that the answers to all of these questions are at the end of the section. So hopefully you learned a little bit more about compound interest. Good luck, and let me know if you have any questions.